Okay, today we're going to look at homework 12. So we're looking at some more quadratic equations and expressions. We're looking at those in application problems or word problems, but I'm going to show you how to solve them and get all of your solutions by graphing. Okay, so this should be really easy, really quick assignment. If you did homework 11 and you practice solving and factoring by graphing, then this will be even easier. I'm going to show you how to do it in the Desmos calculator because that's going to be the easiest. But you can do the same thing with the TI Inspire calculator if you picked yours up, and you'll use graph trace, just like we did on homework 11. Okay, so I'm just going to walk you through 5 sample problems of your homework. There's only 5, so my problems will look just like your problems but with different numbers. Okay, so number 1, the area in square feet of a rectangular field is x squared minus 140x plus 4500. In width, the feet is x minus 50. What's the length? So we're going to go over here to our Desmos calculator. We're going to type in that expression. So x squared minus 140x plus 4,500. Now, depending on what your graph looks like, you might have to do some zooming in or out, okay? So we're looking for the 0. So where it crosses the x-axis, sorry. So we have 50 and 90. So the width is x minus 50. So that means our length is x minus 90. So that's like that factoring by looking at the graph that we did in the last lesson. Okay. All right, the next one, your class is selling a box of flower seeds as a fundraiser. The total profit depends on the amount X, blah, 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 blah. What we need is that equation. So we have, instead of P, we're just going to use Y equals, or you can leave it out. It doesn't matter. But negative 0.5X squared plus 36X minus 128. Okay, so I'm going to drag my graph here a little bit. So to make the desired profit, the smallest amount you can charge for each box is what? So we want a profit of at least $394. So P stands for profit. So instead of that Y or that P, we need to type in 394. So 394, there we go. It adjusts our graph a little bit. And we want the smallest amount you can charge. So I think that we are going to this one, and we'll check it and see. So 20.125, so rounding to the nearest cent, so 20.13. There we go. So you're looking for that smallest x-intercept there, and make sure you look to see where it wants you to round. Here it says to the nearest cent, so the nearest cent is the 10th place. Okay, here's our next one. We're talking about a cannon being fired from a certain height at a certain angle, and here we have the quadratic equation. So we're going to start, you can do y equals, or you can leave it off, but we're going to start with negative 4.9x squared. I'm using x instead of t. We talked about that in lesson 11. So 30.5x plus 8.8. Okay, so here we have our nice little graph. I'm going to zoom in a little bit just so it's easier to see. And so let's see. The cannonball will strike the ground after about how many seconds? So if you look, okay, here's a great visual example. So the cannon is shot and it hits over here. So on our graph, it's going to be this x-intercept way out here. Okay, so it's 6.5010. It says round to the nearest hundred, so that's 6.50. There we go. All right, number 4. We're talking about an athlete who does shot put, and we have the little graph here, and we are going to graph that expression. So I'm just going to edit my numbers here. So negative 0.01x squared and 0.7x and then 5.3. Okay, and I'm going to zoom out a little bit so I can see my graph, and it wants to know the maximum height. So that means our maximum. That's our point at the very, very top. And so I think, let me zoom it out a little bit more. That'll help me see. Okay, I think that it's right here, because that's giving me a good little point. So the maximum height, that's your y coordinate, so that's 17.55. And then how many feet from the point of release, that's our x, so that's 35. Good deal. And then the shot's maximum horizontal distance, so that's as far as it goes to the right, and that's on the x-axis, so it's 76.893. And it says round to the nearest tenth, so that's 89, so rounds to 9. And then from what height was the shot released? So that's your y-intercept. So you can see the y-intercept from the expression, it's that 5.3, or you can look at it on the graph. So 5.3, there we go. Now the last one is very, very similar. I'm just going to edit my equation in here, so negative 0.2x squared, and then it's 1.2x, and then plus 7 at the end. Okay, so here we go. I'll zoom it in a little bit. All right, so the maximum height, again, so we find our maximum, looks like it's right here. So the height is 8.8, and the x is 3. And then travel horizontally, that's the farthest to the right on that x-intercept, so 9.633. We're rounding to the 10th, so 9.6. And then we want the graph that matches. So if you look, our y-intercept is between 5 and 10, so that tells us it's going to be this one. So B. And there we go. And those are your 5 problems. So you can do your problems the exact same way that I did these. You can do a split screen and watch the video and do your problems at the same time, or you can pause and go back and forth, whatever you need to do. But this assignment is designed to be easy for you. Use your calculator, use this Desmos calculator, and do it that way, okay? So if you have questions or need help, let me know. I'd be happy to assist you. But if not, have a great rest of your day.